Hi students, in previous 3 lectures we have studied so many concepts of continuity and limit. Now the last 2 concepts from the continuity, in that first one is continuity of the function in an interval. Continuity of function on closed interval AB. We know that every function has some graph. When we consider any function y is equal to f of x, then for every value of x there should be the value of y. It means it has some graph. Suppose this is a graph of the function y is equal to f of x, and if you take any interval values of x, suppose this is point x is equal to a and this is point x is equal to b. Now these are nothing but the values f of a and f of b. This is f of a and this is f of b. Now to say that this function f of x is continuous in this interval a and b, we have to remember 3 important points. Any function f of x is said to be continuous in closed interval AB if, remember these 3 points. Number 1, f of x is continuous from left of a, from right of a. What it means? Limit of f of x as x tends to a plus must be equal to f of a. Means the value of function at x is equal to a, value of the function at x is equal to a, and limit of the function in neighborhood of a must be equal, but from the right side of a. Now second, f of x is continuous from left of b. F of x is continuous from left of b. It means limit of f of x as x tends to b minus must be equal to f of b. Means left hand side limit at x is equal to b, it must be equal to f of b. Now when we consider the continuity of the function in interval AB, these points are not so important. Now function gives us graph from a to b like this. Means this function, this point is said to be at x is equal to a. This is a point at x is equal to b of this function f of x. Now this function has its limit and value are equal. It means we can say that this function is continuous from right of a, this function is continuous from left of b, and third point is f of x is continuous at every point C in interval AB, in AB, closed interval AB. That is what? Limit of f of x as x tends to C minus must be equal to limit of f of x as x tends to C plus is equal to f of c. Means that function must be continuous at every point in this interval. या इंटरवल मध्ये प्रत्येक पॉइंट साठी ते फंक्शन कंटिन्यूअस पाहिजे. At that time we can say that that function is continuous in this interval, closed interval AB. Function is continuous in closed interval AB. Remember 3 points. That function must be continuous from right side at initial point of the interval. That function must be continuous from left side at end point of the interval, and that function must be continuous at every point between the interval. Then we can say that that function is continuous at every point in this interval, closed interval AB. Now the last concept, intermediate value theorem for the continuous functions. This concept is depend upon the continuity of the function in the closed interval. Suppose a function f of x, is continuous in closed interval AB. It means we have studied on the graph y is equal to f of x is any function. Suppose this is a graph of the function and we take interval x is equal to a and x is equal to b, suppose. Now here we can, from this graph we can easily observe that that function y is equal to f of x is continuous in this closed interval AB, because this function is continuous and it is continuous from right of A and left of B. That's why we can say that that function is continuous in the closed interval AB. Now take any point or any value. Suppose this is y0, this is y0 on y-axis, y0. This is y0 which lie between f of A and f of B. What we have taken? We have taken one value of the function which lie between f of A and f of B, or one value which lie between these. Then this concept says that there must exist, there exists point C in open interval AB such that f of c is equal to y0 or y0 is equal to f of c. Now we will take directly example of this. Now we know that polynomial function is always continuous function. Polynomial function is always continuous function. We will take directly example for this concept understanding. Take function as f of x is equal to x square plus 5x plus 3. Now, if we take two values of x, suppose x is equal to 1 and x is equal to 5, we can easily say that as function is a polynomial function, it must be continuous in this closed interval 1 to 5. Now we will find f of 1. What is f of 1? Put x is equal to 1 here. 1 plus 5 plus 3, that is nothing but 9. And if you find f of 5, then it is 5 square is 25 plus 5 into 5 is 25 plus 25 is 50 plus 3 is 53. Now here we can observe f of 1 is nothing but 9 and f of 5 is nothing but 53. Now if you take, look at this, if you take any value between 9 and 53 for this function, then we'll get x between 1 and 5. Otherwise, if we take, suppose x is equal to 2 now, take x is equal to 2, then we must get the value between 9 and 53. X is equal to 2, then we have f of 2 is equal to, we have it is 2 square plus 5 into 2 plus 3, that is 4 plus 10 plus 3, that is 17, and this value 17 is lying between 9 and 53. Okay? Means either you can take the value of the function between 9 and 53, you will get the value of x definitely between 1 and 5, or if you take any value between 1 and 5 of x, then the value of the function at that point must lie between 9 and 53. It is possible only if that function is continuous in that interval. Means when the function is continuous in the interval and y0 is any value between f of a and f of b, then there exists a point c in the interval ab such that y0 is equal to f of c. This is the last concept of the continuity. Now students, we have studied so many concepts in the chapter continuity. I will revise the just names of that concepts to revise you before solving the exercise. Only one exercise is in this chapter. First of all, we have studied the continuity, definition of continuity. You revise it very well. Then, what is discontinuity of the function? In that we have studied 3 types of discontinuity. In that, jump discontinuity, then removable discontinuity, then infinite discontinuity. We have studied 3 types of discontinuities. Then after that, third concept, we have studied some continuous functions. You have to prepare the notes about these points. Fourth one, algebra of continuous functions, algebra or properties of continuous functions. Then fifth one is continuity in interval. And last one is intermediate value theorem. Prepare the notes for all these 6 points. Continuity of the function at a point, types of discontinuity, some continuous functions, algebra or properties of continuous functions, continuity at interval, and intermediate value theorem for the continuous functions. After studying the concepts of continuity, now we are going to solve the exercise from this chapter. Exercise 8.1. Question number 1. To examine the continuity of the functions. Now in first question, function is given f of x is equal to x cube plus 2x square minus x minus 2, and we have to discuss its continuity at x is equal to minus 2. Now we can easily observe that this function is polynomial function, and to examine the continuity at any point, we are going to use the definition of continuity. For that, we are going to find limit of this function. Limit of f of x as x tends to 2 is nothing but limit of, what is the function given? It is x cube plus 2x square minus x minus 2 as x tends to minus 2. Now, to find its limit, substitute this value minus 2 cube plus 2 into minus 2 square minus of minus 2 that is equal to minus 2 cube is nothing but minus 8. Minus 2 square is nothing but 4 into 2, 8 plus 2 minus 2 means value of the function, limit of the function as x tends to minus 2 is equal to 0. If you try to find f of 2 here, means the value of function at x is equal to 2 directly, it is again minus 2 cube plus 2 into minus 2 square minus of minus 2 means it is minus 8 plus 2 minus 2, that is also 0. Hence we can say that limit of f of x as x tends to minus 2 is equal to f of minus 2. Therefore, it is f of minus 2. Therefore, you can say that f of x is continuous at x is equal to minus 2. As we can easily say that in CET point of view, we can easily observe that it is a polynomial function, and in continuous functions we have studied that continuous function, polynomial function is always continuous at every point, means obviously it is continuous at x is equal to minus 2. Now look at this second function. Second function is given in different way. F of x is equal to sin x for all the values of x less than or equal to pi by 4 and is cos x for x is greater than pi by 4. Now we are going to discuss the continuity at x is equal to pi by 4. For that, as function is different for less than and greater than values for pi by 4, we are going to find LHL and RHL separately here. LHL means limit of f of x as x tends to pi by 4 minus, and for this function is sin x as x tends to pi by 4 minus. Substituting this value here, it is sin pi by 4 and its limit is 1 by root 2. We know that the value of sin pi by 4 is 1 by root 2. Similarly, we can find limit of f of x as x tends to pi by 4 plus, that is limit of cos x for x tends to pi by 4 plus. Substitute this value, it is cos pi by 4 and cos pi by 4 is 1 by root 2. And f of pi by 4 means value of the function is equal to x is equal to pi by 4 के लिए function sin x है तो ये बनेगा sin pi by 4 and we know that sin pi by 4 is 1 by root 2. Observe these three values carefully. Left hand side limit, right hand side limit and value of the function all are equal, means we can say that limit of f of x as x tends to pi by 4 minus is equal to limit of f of x as x tends to pi by 4 plus is equal to f of pi by 4. Hence we can say that this function f of x is continuous at point x is equal to pi by 4. pi by 4 के लिए ये फंक्शन कंटिन्यूस हो गया. अब देखते हैं तीसरा एग्जांपल. तीसरे एग्जांपल में फंक्शन दिया है x स्क्वायर माइनस 9 अपॉन x माइनस 3 फॉर x इज नॉट इक्वल टू 3, मीन्स फॉर लेस देन 3 एंड ग्रेटर देन 3 function is same, but for x is equal to 3 its value is given 8. For that we are going to find its limit. Then find the limit of the function. Limit of x square minus 9 upon x minus 3 as x tends to 3, that is equal to, we can say that it is limit of, now x square minus 9 upon x minus 3, it has two factors x plus 3 into x minus 3 divided by x minus 3 as x tends to 3. In this function, there is no need to find LHL and RHL. We are going to find directly the limit of the function at x is equal to 3. As we know that x tends to 3 means x is not equal to 3, means this x minus 3 and x minus 3 we can cancel it. Limit of x plus 3 as x tends to 3, substitute this value, it is 3 plus 3 means it is 6. Hence we have limit of f of x as x tends to 3 is 6 and given, but f of 3 is given 8, means these values are not equal. Limit of f of x as x tends to 3 is not equal to f of 3. Hence we can say that f of x is discontinuous. At x is equal to 3. Why it is discontinuous? Because limit of the function and value of the function are not same, they are different. Hence we can say that that function is discontinuous at x is equal to 3. Now observe these three examples carefully. We are going to teach a second question. Okay students, now question number 2. You can read the instruction from the question. Instruction is examine the continuity of the following functions for the point indicated against the function. First question is f of x is equal to x cube minus 2x plus 1 if x is less than or equal to 2, 3x minus 2 if x is greater than 2, and we have to discuss the continuity at x is equal to 2. Obviously, function is different for x is less than 2 and greater than 2. We are going to find LHL and RHL. While finding LHL, limit of f of x as x tends to 2 minus is equal to limit of x cube minus 2x plus 1 as x tends to 2 minus, that is equal to, substitute these values here, 2 cube minus 2 into 2 plus 1, that is equal to 8 minus 4 plus 1, that is 8 plus 1 9 minus 4 is 5. Similarly we can find RHL. RHL is limit of f of x as x tends to 2 plus, and for 2 plus function is 3x minus 2 as x tends to 2. Substitute this value, 3 into 2 minus 2 means it is 6 minus 2 is 4. Easily we can observe that the left hand side limit and right hand side limit are different, means we can say that limit of f of x as x tends to 2 minus is not equal to limit of f of x as x tends to 2 plus. Hence we can say that this function f of x is discontinuous, means it is not continuous, discontinuous at x is equal to 2. x is equal to 2 के लिए ये function discontinuous हो गया. Look at for second example. Function is given x square plus 18x minus 19 divided by x minus 1 for x is not equal to 1, means for less than 1 and greater than 1. This is a rational function, remains constant, means no need to find LHL and RHL separately. Directly we can find the limit of the function as x tends to 1. Therefore, limit of f of x as x tends to 1 is equal to limit of x square plus 18x minus 19 divided by x minus 1 as x tends to 1 is equal to, now minus 19 has two factors. It is a quadratic polynomial, and quadratic polynomial can factorizable. Minus 19 has factors 19 and minus 1, means it has two factors, x plus 19 into x minus 1 divided by x minus 1 as x tends to 1. Now to cancel this x minus 1, we know that as x tends to 1, x is not equal to 1, means x minus 1 is not 0. Hence we can cancel them. That is equal to limit of x plus 19 as x tends to 1. This is nothing but 1 plus 19, 20. And this is the value of the function f of x as x tends to 1. And f of 1 is given 20. For x is equal to 1, it is given 20. Means limit of the function, limit of f of x as x tends to 1 is equal to f of 1. Hence we can say that f of x is continuous at x is equal to 1. x is equal to 1 के लिए ये फंक्शन कंटिन्यूअस हो गया. अब देखते हैं आगे फंक्शन है x upon tan 3x plus 2 for x is less than 0 and 7 by 3 for all the values of x greater than or equal to 0. यानी यहाँ पे LHL निकालना है. RHL निकालने के लिए फंक्शन है कांस्टेंट, और आपको पता है कि कांस्टेंट का लिमिट हमेशा कांस्टेंट होता है. पहले हम फाइंड करेंगे लेफ्ट हैंड साइड लिमिट LHL, that is equal to limit of x upon tan 3x plus 2 as x tends to 0. x की कंटिन्यूटी, अपने फंक्शन की कंटिन्यूटी हमें x is equal to 0 के लिए चेक करनी है. तो यहां पे फॉर्मूला यूज करेंगे हम. दिस इज नथिंग बट लिमिट ऑफ, इसको लिखेंगे 3x अपॉन tan 3x इंटू 1 by 3, ये 3 एडजस्ट किया, प्लस 2 एज x टेंड्स टू 0. अब ये जो टर्म है इसका लिमिट आएगा 1 बिकॉज ऑफ वी नो दैट लिमिट ऑफ tan x अपॉन x is 1. Similarly, limit of x upon tan x is also 1. Hence, its limit is 1 into 1 by 3 constant plus 2 constant as it is. 1 by 3 plus 2 is nothing but 3 into 2, 6 plus 1 is 7 by 3. Means this is limit of f of x as x tends to 0 minus. 0 minus यानी LHL आया अपना 7 by 3. RHL और value. From this function directly, we can say that limit of f of x as x tends to 0 plus and f of 0 both are equal. They are nothing but 7 by 3. Means all the three values are equal. Therefore, LHL is equal to RHL, means limit of f of x as x tends to 0 minus is equal to limit of f of x as x tends to 0 plus and f of 0, all they are equal. Therefore, we can say that f of x is continuous at x is equal to 0. It is continuous at x is equal to 0. आज हमने 2 क्वेश्चन सॉल्व किए जिसमें 3 सब क्वेश्चंस थे. आगे के लेक्चर में हम रिमेनिंग क्वेश्चन सॉल्व करेंगे. आप एक्सरसाइज 8.1 को सॉल्व करते रहो. जो भी डाउट्स है मुझे व्हाट्सएप ग्रुप पे आप उस क्वेश्चन के नंबर्स लिख के भेजो. वो क्वेश्चंस मैं आपको यहाँ पे सॉल्व करके दूंगा. थैंक यू.